All right. So we've got all kinds of things that we can use for this. We're looking for a time for the total trip right now. We generally want something that is going to have, you know, everything involved that we need it. We need an equation that has time in it for sure. Okay. We can use a couple different equations. All right. But the easiest is the one we should use. And really, we can go back to this equation here. And we can find out what that time is. Now, in this case, all we really need is the initial velocity, because we know that these two will have the same magnitude, but opposite directions. So, in solving for time, the first thing I'm going to do is substitute negative v naught in for the final velocity when it hits the ground there. So I've got negative v naught is v naught plus g times t. Let's solve this for t. I have negative 2 v naught g times t by both sides by g. I've got t is equal to negative 2 times v naught over g. Substituting our values in there, we should be getting 5.10 seconds. Now, you may have noticed something. T is 5.10 seconds. What was the time that it took for it to go up to the apex? There we go. 2.55 seconds. Now, these numbers involve some rounding, okay? But one thing we can see is that the time for it to make the total trip is going to be exactly twice that number, okay? This is what we call a symmetric equation, or a symmetric situation, where the upwards trip exactly mirrors the downwards trip. We start at a certain velocity, and it goes to 0 under that constant acceleration. And then starting at 0, it undergoes that same constant acceleration in the downward direction and ends with the same velocity it started. And every point along the way is going to have an analogous point on the way down. Okay? We'll see this a lot in physics, so there you go. Yes, I guess we're done here, at least with this one.